It's not the same as your standard XY plane. All right, it's a circular graph. The ordered pairs, two numbers. The first number in the ordered pair represents the radius. And the second number in the ordered pair is your angle. Now, for example 1, we're going to do it in degrees because it's a little easier than radians. This grid is set up like the unit circle. So let's go around and label it. This will be 0, 30, 60. I'm just going to do my 30 degrees. Just counting by 30s, multiples of 3s. Okay, so A says 90 degrees. So this is 90 degrees right here. This is my 90 degree. Every ring is a radius. So this is R1, R2, R3, R4, R5. So this one only has 5 rings. So the point 490 is right here. That's point A. Point B is 210, 3. So that would be here. This is 210. I'm going to count 1, 2, 3. I'm landing right there. That's B. C is a negative 1, 120. So let's talk about negative. So here's 120. Now, polars, the axes, the angles are actually extended. So 120 degrees shares the same line as 300. So when it's negative, that means instead of me counting forward towards the 120, I'm counting backwards towards the 300. So this is where that point would fall, right here. So this point is exactly the same as positive 1, positive 330. There's more than one way to name a point. So these are the exact same point. Yep, it is 300. I was just joking. Definitely 300, not 330. I did that every period. I don't know why. That's so weird. Okay. All right. 60 degrees. So this is 60. 60 shares the same as 240. So instead of me counting forward, because it's a negative 3, I'm counting back. 1, 2, 3. I'm landing right there. That's point D. All right, point E. So point D, let's go back to point D. Point D could also be called what? What would be another name for point D? 3, 240. Good job. Same thing. That's an ugly 3. I don't like that 3. Do better. Okay. All right. E. Both are negative. So remember, when we talked about angles, when you go counterclockwise, it's positive. But when you go clockwise, it's negative. So I'm going to go around and label these all using negative. So that means this is the same as negative 30. This is the same as negative 60. This is the same as negative 90. So I'm just going to go around. This is exactly the same as when it was on the unit circle. Okay. So we have a negative angle. So I have a negative angle, negative 330, which would be here, which is the same as positive 30. But R is negative 2.5. So I'm actually going to count backwards. And I'm going to land right in front of capital B. Okay? Because this is the same, they share, this shares. Okay, so let me go ahead and highlight that. So we're starting here, but negative 330. It also has a negative radius, so we're counting back 2, 1, 2.5. So we're going to stop right there in front of B, and that would be E. All right, F, negative 45 would be here, but I'm counting forward. So I'm going to be right here on the edge, almost off the grid. That's F. And then G, 120, negative 2. 180, sorry, 180, negative 2. So I'm going to count backwards. And I'm landing right there. So it's important that because you are going to use a graphing calculator to create your design, but you need to know where to put the pins on the grid. Like you will need to transfer that design to the board. So you need to know where to put pins. So that's kind of what we're talking about. All right, so now let's switch to radians, which is where we will be. Okay, nothing is in degrees. So I'm going to go ahead and clear this off because I'm going to recircle or number this grid in radians. This is 0, pi over 6. So I'm just going to do my 30s again, 2 pi. So this would be 2 pi over 3, 5, 6, 7, 8, 9, 10, 11, 12. So 5 pi over 6 is here. 3. 1, 2, 3. You're going to land right there. That is H. For the letter I, 2 pi over 3, but we're going back. We're not going forward. I'm going backwards towards 5 pi over 3. So this point is going to be in Q4. So the point negative 2, 2 pi over 3 is in quadrant 4. And that is going to land you right here. And that would be I. J, pi, go out 4, 1, 2, 3, 4. Right here, that's J. K. K is 3 pi over 4, which is in quadrant 2. So this is 3 pi over 4. Am I going to stay in quadrant 2 or am I reflecting it to quadrant 4? The radius is negative 2. Going to quadrant 4. I and K. Did I put I on the wrong spot? I think I did. Yeah. Okay. I was about to say they should be next to each other. Okay, that's fixed now. because that didn't look right. Okay. All right, next is M. So M pi over 6, but it's a negative. So I'm going to reflect that into quadrant 3. So I'm going to go back 1, 2, 3, 4. I'm right here. I skipped L again. Why do I keep doing that? That's so weird. It must be something about that letter. I don't like it. Yeah. Okay, let's go back to L. All right, so 11 pi over 6. This is 11 pi over 6. Count forward 3. 1, 2, 3. So right here should be L. And then lastly, okay, negative 3 pi over 2. What angle would that be positive? Positive pi over 2. So this is the same as positive pi over 2. This is the exact same line. But I'm not going to count forward 5. I'm going to count backwards 5. So I'm going to be right there, almost off the grid. All right. Any questions about how to plot the points? Okay. All right, so now let's talk about how you graph some circles. We're going to talk about the different equations. All right, R equals 2 is a circle. All you're doing is finding that second ring and tracing it. That's R equals 2. That's the most simplistic polar graph. 2 pi over 3. This is where 2 pi over 3 is. But when you're drawing it, we go, because remember, 2 pi over 3 is generous. It goes all the way back. So your line is in 2 quadrants.
Question. Are the arrows necessary?
For a line, technically. But it's okay. All right, what's that? Negative 7 pi over 6. So I'm going to count. I'm counting by 6. So this would be negative 1, negative 2, 3, 4, 5, 6, 7. So this is negative 7 pi over 6. And that would be that line. Any questions? So there is one polar question on your final exam. Let's talk about it. You won't have to graph it, but you do need to recognize which of the 5 special types of equations we have from looking at the equation. All right, so let's talk about how you can identify it. They all have a theta. All of them have theta included in the equation. Now, circles and limicons, I want you to notice that both of these, theta is multiplied by 1. Okay? So if it's not a 2 theta, a 3 theta, then we know it's either a circle or a limicon. Limicons have the plus minus though. So you see, that's how you can tell a limicon apart from a circle. The third is the rows, okay? Now rows, it looks very similar, the equations, but there will be a number here. Not 1. It's going to be a 2, a 3, a 4, a 5. That's going to say how many petals you have on the rows. So that's how you can tell the difference between a rose and a circle. Lemniscate, which looks like this. I'm going to kind of, well, so a circle is just a circle. It's a special circle. A limicon kind of looks like this. A rose, I mean, it doesn't actually look like a rose, but, ooh, that's ugly. But it's like petals. That's kind of a rose. And we're going to actually talk about how to graph these. A lemniscate, though, is just a loop-de-loop. And you can tell that it's a lemniscate because that's the only one that's R squared. Thank you. The spiral is the only one that doesn't have a sine or a cosine, and it looks like a spiral. It just spirals around. All right, so now let's see if we can do it. Number 1, what kind of graph is that? Which of the 5? It has an R squared. Only one of them has an exponent. That's the lemniscate. 2 doesn't have a sine or a cosine in it. So that's a spiral. 3 has a number right there. That's going to make it a rose. All right, I'm going to give you all 60 seconds to take a guess on 4 through 9. Just take a guess. Yes.
Is it like exactly like this on the test, or is it just like one singular one?
Is it, what do you mean? Say that one more time.
Like, is it going to look like this on the test, or is it just like literally one singular question like that?
It's going to say, given the equation R equals blah, 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 which type of graph is it? A, lemniscate. B, rose. C, circle. And you have to select what kind of graph given by that equation. Does that make sense? Did I answer your question? Okay. So that's why I'm trying to give you some of the hints. And so like if I see a R squared, we know that's a lemniscate. If it doesn't have a sine or a cosine, that's automatically a spiral. So there's 2 spirals up there. If it has a plus or a minus and a sine or a cosine, then that's a lemicon. All right, who agrees with my 6 answers? All right, so we're going to go through all 5 graphs, Monday, Tuesday, and Wednesday. And then Friday, you will get started on the project. All right, so let's get started with the circle. So first thing first. There's 4 types. Notice that these circles are not centered at the radius. All right, so this isn't just an R equals 3 or, I mean, not centered at the radius, centered at the origin. All right, this is not a circle that's centered at the origin. The center is somewhere else. If you want it to face, that's good, left or right. If you want a circle that's facing left or right on your project, you need to use cosine. Cosine makes it go left or right. Okay. Sine gives you a circle that faces up or down. And we're literally, because you will eventually graph this online digitally, but I want you to know how to get the points on your own because you do need to turn in a table with your projects. So I know that this graph, which way do you think? First of all, is this up or down or left, right? Left, right. Now, let's just take a guess. It's a negative. So do you think it's going to be left or right? Left, because on the left side, X is negative. So this is going to give me a left-facing circle. So to be simple, even though I know my angles are in quadrants 2 and 3, I'm just going to use the coordinates in 1 and 2, which tells me because I'm not using 3, all of my points in quadrant 1 they're going to be backwards. They're going to be negative. So let's just use our unit circle, regular numbers, regular, degular. So let's just do the first 2 quadrants. And it's really all about speed after this. How fast can you get your points? How fast can you type it in the calculator? So I'm going to go ahead and transfer those here. 0, pi over 6, pi over 4. And this is the learning curve because nobody has ever graphed on a circular graph before. Maybe you have in physics or something, I don't know. But we just got to get, a feel of it. So what I want you to do, pick up your calculators and make sure at the top corner it says RAD. Okay, so everybody find that green key. Does everybody see that green key, that second function key? Next to it, it says mode. Hit the mode button. Thumbs up if you found the mode button. Who's found it? All right, now that top row, that's the different types of angles, okay? There's degrees, radians, and graduated radians. We don't do anything with graduated radians, okay? That's for like Calc 5 and 6. We're just in the regular radian, okay? RAD. Hit enter. Make sure that's highlighted. Hit enter so that it's in radians. And then hit clear, and that's going to take you out of the mode. Now, at the very top right corner in tiny, tiny, tiny letters, you should see RAD. All right, that means we're in the right mode, so we're ready. So we're going to pick up our calculator, and we're going to type these in as fast as we can. It's all about speed, to be honest. So type in -2, cosine 0, hit enter. -2, cosine. Hit the fraction button. Pi, the symbol for pi is 3 hops down from the green key. Pi over 6. Now it's going to tell you something funny like -√3. Whose calculator says that? We want decimals. Hit the button above enter that has the 2 triangles facing left and right. We only go out to the 10th place. That should be -1.7. -2, cosine, hit the fraction button. Pi over 4. All right, I am going to give you all a chance to finish out the table. I'm going to come around and help those who aren't getting the numbers. I'm not going to show the answers, though, just yet. Hold on, let me fix my screen because I done messed it up. Wait, that's not what I'm trying to do. I'm trying to come over here and do that. Okay. All right, I'm going to fill in my table. Then I'll come around. Now, you should notice, because it's symmetrical, your numbers, after you get to pi, after pi over 2, they should start repeating themselves, but they should be positive, though. trying to do?
Trying to get its ratings. I don't know if the videos are kind. It says to hit the little book. Yeah, and then I scan that and I search for ratings and it says to hit the little book, but hitting the book doesn't do anything. Yeah.
We don't got time for that.
Yeah.
Not that deep. Okay, that looks good. Oh, that's too much.
Oh, come on.
Looks good. Okay. Okay. So, this is what you should have. Didn't, yeah. This is what I have. Who had that? So now we're going to graph it. We just got to know how to plot these points. All right. 0, I'm going back to. So I'm landing right here. At pi over 6, I'm going back about 1.7, which is just under the -2. We got to approximate, do the best we can, y'all. Pi over 4, just going down more. Pi over 3 is -1. Okay. Now when we swing over to quadrant 2, all of our points are positive. But they're just a reflection because the circle is symmetrical. 2 pi over 3 is at 1. 3 pi over 4, about 1.5. And then a little closer right under 2. So if I zoom in, this is a tiny circle though. Now, I don't recommend you do anything that small, but just know that this number determines how big your circle is. All right? All right, now I want you all to do number 2 using the exact same values that you used in number 1. But now it's 3 sine theta. What kind of circle is this going to be? Left, right, up, or down? Up. Up because it's a +3. All right, so as fast as you can, I want you to get those points. And we will pick up here tomorrow. I'll show you the points that I got because we are just about out of time and I want to show you your tests.